Okay, so imagine this. You and your friends are trying to plan a surprise party,
All right.
but none of you, trust each other enough to actually coordinate directly.
Okay.
You need some way to agree on all the details, the
Mm.
time, the location, who's getting the cake,
Right.
without anyone, accidentally tipping off the guest of honor, right? It's
Yeah.
kind of impossible.
That's the challenge of building trust in a decentralized system.
Mm.
And it's even more difficult when you're talking about something with real value, like money, right?
Right,
Yeah, it's like that classic thought experiment, the Byzantine generals problem,
right,
where a bunch of generals need to coordinate an attack, but some of them might be traitors.
right.
How do you make sure everyone acts together even when you can't be sure who's reliable?
So how do you create a system that's, actually reliable when you can't even be certain everyone's playing by the rules? And that is what we are diving into today.
Exactly.
The Ripple Protocol Consensus Algorithm, or RPCA.
Yes.
Bit of a mouthful, we know.
It is, yeah.
But trust us, it's cool stuff.
Right.
We're going deep into this Ripple Consensus white paper. Thanks for sending this over, by the way, to really understand how they pull it off.
Yeah, no problem. And the best part about this white paper is that it doesn't shy away from those really, fundamental questions. It lays out the core problems that any distributed payment system has to solve: correctness, agreement, and utility.
Okay, so let's break those down. Correctness, that's
Sure.
making sure that only the legit transactions actually go through, right?
Exactly.
It's like your digital bouncer, keeping the riffraff out.
Exactly.
Hmm.
Then you've got agreement, which is all about making sure everyone's on the same page about who owns what. Because can you imagine if different parts of the network disagreed about, your account balance?
Oh, man.
It'd be chaos.
Yeah.
Total chaos. So agreement, that's what prevents those disastrous forks we hear about, in the blockchain world.
Right. And of course, none of it matters if the whole system is just, crawling.
Right.
Right. That's where utility comes in.
Yeah.
We need those transactions to be processed quickly and efficiently, or nobody's going to use it.
Exactly. It's like a three-legged stool. You need all three of them for the whole thing to actually work.
Yeah.
But before we jump into how RPCA actually tackles these challenges, let's make sure we're all speaking the same language here. The white paper does a really good job at defining the terms that it uses, which I think are really important for understanding, the whole process.
Yeah, because jumping into the technical stuff without that foundation would be I don't know, trying to put together furniture from IKEA without the instructions.
Yeah, exactly.
Frustrating.
Exactly. So starting with the basics, we have servers. Those are basically just computers running the Ripple software. Think of them as the players in this consensus game.
Okay.
Then you have ledgers, which are kind of like the master record books of who holds how much currency.
Right.
And the last closed ledger is the most up-to-date version of that record that everyone agrees on. And this is where it gets really interesting. Each server has its own unique node list, or UNL. And this is basically a server's own list of other servers that it trusts to give it accurate information.
Okay, so it's not like trusting everyone blindly. It's more about diversifying your sources.
Exactly. And the white paper uses a really interesting example to illustrate this. What are the chances of, say, the Anti-Defamation League and the Westboro Baptist Church colluding to defraud a financial network?
Okay, now that you mention it, seeing those two agree on anything would be I don't know, witnessing a polar bear and a penguin start, a synchronized swimming duo. Highly unlikely.
Exactly.
Yeah.
And that's the beauty of having this diverse UNL. By choosing servers from different backgrounds, different industries, even geographical locations, you minimize the risk of everyone being in cahoots to, game the system.
So even if a few bad actors sneak in there,
Right.
they're kind of outnumbered and outgunned by the sheer diversity of the network.
Exactly.
Okay, so that UNL sounds like a pretty crucial piece of the puzzle then.
Absolutely. The UNL is central to how each server decides whether to accept or reject these proposed transactions. But the real magic happens when we look at how all of these individual decisions come together to form a network-wide consensus.
Right.
And that is where the RPCA really shines.
All right. So we've got our servers, we've got our ledgers,
Yeah.
our carefully curated UNLs. Now let's see how they all work together to actually make this whole consensus thing, actually work.
Yeah.
Because at the end of the day, it's not about understanding the pieces. It's about understanding how they all fit together to create a secure and efficient system.
You got it.
So we've gotten our heads around the players and the playing field. But how does this whole RPCA thing actually play out in real time?
Okay.
It's got to be more than just servers politely asking each other, hey, Do you think this transaction is cool?
You're right. It's a little more dynamic than a polite conversation right now.
Right.
Imagine like a bustling marketplace.
Okay.
But instead of vendors selling their wares, it's servers proposing transactions. That's the RPCA in action. It's this constant cycle of proposals and then votes and then ultimately a decision. Do we accept this transaction or do we reject it?
So it's like this constant digital debate going on with all these servers campaigning for their favorite transaction.
Exactly. Each round starts with servers gathering up all the valid transactions they've seen that haven't been officially added to the ledger yet, and they package these into what the white paper calls a candidate set. It's basically a server saying, hey, everyone, I think these transactions deserve to be in the official record.
Okay, so it's like each server is curating its own little mini ledger
Exactly.
of potential transactions.
Yes.
But the real test is like getting everyone else on board.
Yeah.
Convincing the whole marketplace.
Exactly. And this is where those carefully chosen UNLs come back into play. So each server looks at the candidate sets that are proposed by the servers on its UNL, right, its trusted circle, and then it's time to vote.
And it's not just a simple majority rules situation, is it? This white paper mentioned something about a magic number.
Ah, yes. The magic number here is 80%. So for a transaction to get the green light, it needs at least 80% of a server's UNL to agree that it's legitimate.
Wow.
This high bar is crucial for ensuring what the white paper calls correctness, which is making sure that only valid transactions are actually being added to the ledger.
80%. So that's a lot stricter than like your average election. It's more like needing 8 out of 10 of your closest friends to agree to let you borrow their car.
Right. And that level of scrutiny is what makes it secure. The white paper goes into all these different types of fraudulent transactions, and it's so cool how RPCA can handle each one.
Wait, so not all fraud is created equal in the eyes of RPCA?
Absolutely not. So you might have a simple case of, like, someone trying to spend money they don't have,
Right.
which is easy to spot, right?
Yeah.
You just check the last closed ledger. Or you could have something way more devious, like it's someone trying to double spend the same funds in 2 different transactions.
Ooh, sneaky. So how does RPCA catch that?
Well, because everyone is working from the same set of rules and looking at the same last closed ledger,
Right.
these double spend attempts really stick out,
Okay.
like a sore thumb. Imagine trying to, buy a coffee and a car with the same ripple
Right.
at the exact same time.
At the same time, yeah.
The RPCA would be like, nope, I see what you're doing there.
Yeah. Okay. That makes sense.
Oh,
But even if, like, individual servers are good at weeding out the bad transactions, we still need the entire network to all agree, right?
yes.
Otherwise, it's just total chaos.
Exactly. That's where agreement comes in. It's
Oh.
arguably even more crucial than individual correctness.
Okay.
And that's where this whole idea of a fork comes into play.
Okay, fork still sounds a little ominous in, like, a financial context.
It does, doesn't it?
Yeah. What does a fork look like in the Ripple world? Paint me a picture.
Okay. Imagine different parts of the network disagreeing on which transactions are valid. That's a fork.
Okay.
It's basically this situation where you have multiple versions of the truth, and it leads to confusion and potentially disaster.
So it's like a choose-your-own-adventure book. But instead of a fun story, we're talking about financial records.
Right.
And there's no going back to choose a different path.
Exactly. But luckily, the RPCA has these really elegant mechanisms for preventing those disastrous forks from ever happening.
Okay, good. How do you stop a whole network from splitting off in different directions?
Well, connectivity is key.
Okay.
Remember those UNLs, right?
That's where I get
Those
it.
circles of trust that each server relies on.
Right.
The white paper really stresses how those UNLs, they can't just exist in isolation. There needs to be enough overlap and communication between them to prevent any one group from, going rogue and creating their own separate conflicting version of reality.
So it's like this giant web almost where
Yeah.
information about all these transactions is constantly flowing between all these overlapping circles of trust.
You got it. And you know what? The white paper actually gives a really helpful visual for this. Figure 2, if you're following along.
Okay.
It shows how this interconnection between UNLs makes it virtually impossible for a fork to actually occur. Think of it like, having a bunch of security cameras, right? All covering the same area. Even if one camera goes down, the others have still got you covered.
Right. So even if some servers tried to, like, collude with each other and create a fork,
Right.
the interconnectedness of it all makes it really hard to actually pull off.
Exactly.
Okay, so we've got correctness, we've got agreement. What about utility?
Ah, yes.
At the end of the day, this all has to happen in a reasonable amount of time, right?
Yeah. Of course. I mean, a system that takes a week to process a transaction isn't very useful to anyone, is it?
No.
And that's where the elegant design of the RPCA really shines.
Okay, spill the beans. What makes it so speedy? What's the secret sauce? So we've talked about how our PCA is secure, how it makes sure everything's accurate, but what about speed? I mean, Caffeine, we live in a world of instant gratification. Nobody wants to wait around forever for a transaction to go through.
Right. Totally. Luckily, though, the people who designed RPCA, they were way ahead of the curve on that. Remember we were talking about the algorithm running in these rounds?
Yeah.
Well, those rounds, they don't just go on endlessly. The white paper points this out. There's a limit, like a built-in time constraint on each consensus process.
Okay, so no endless debates dragging on and on. I like that. But what about those servers out there that might be running a little slow? Maybe they've got like a bad internet connection, something like that. Could those servers hold the whole network back?
It's a great question, and the white paper actually addresses it head on. So the RPCA has this really smart system for keeping an eye on those slowpokes, you know?
Yeah.
It's constantly monitoring what's called latency, which is basically how long it takes each server to respond.
Gotcha.
And if a server consistently takes way too long, well, it gets flagged.
Oh.
And it might even get removed from everyone else's UNL.
So it's like being voted off the island, basically, for
Yeah.
slowing down the tribe.
Exactly.
No more dawdling allowed.
Exactly. You got to be efficient. And it actually gets even more interesting. The white paper talks about this other neat trick for really speeding things up. It's a 2-second proposal window.
A 2-second window? Okay, that sounds kind of stressful.
It does. It's very short, but it serves a really crucial purpose. So during that super short window, servers can propose their candidate sets. And this makes sure that everyone gets a chance to be heard, right?
Right.
It prevents any one server from dominating the conversation.
It would be kind of unfair if only one server got to, run the whole show.
Yeah.
That kind of defeats the purpose of having a decentralized system, right?
Exactly. It'd be like a democracy where only one person gets to vote. Speaking of democracy, the white paper also mentions this idea of a default UNL.
Okay, a default.
Yeah, so it's like if you're new to the network, you don't necessarily know which servers to trust yet.
Yeah.
So this default UNL is like a pre-selected group that the system recommends.
Got it. So even if you're totally new, you're not just thrown to the wolves.
Exactly. It's like a starting point, you know?
Yeah, like training wheels. Training wheels for decentralized finance.
I like that, training wheels. And that's not all. RPCA has even more up its sleeve. And remember we were talking about forks, those nightmare scenarios where the network basically splits? Well, RPCA, it actually has this built-in alarm system for that too. It's called the network split detection algorithm.
Okay, there's a lot going on under the hood here. How does that work?
So basically, every server is keeping track of how many other servers are actively participating, right? If one server notices a sudden drop, like, whoa, where'd everybody go?
Red flag.
Exactly, raises a red flag.
Okay, smart. But what happens next? How do you actually stop a split that's, in progress?
So to avoid false alarms, because, sometimes servers just have temporary internet hiccups.
Right, yeah, of course. Happens to the best of us.
Exactly. They can issue what's called a partial validation, basically a little I'm okay signal to prevent panic.
Right. Communication is key.
Communication is key. So the network's actually surprisingly chatty for something that deals with cold, hard digital cash.
I kind of like that, though. It's reassuring, all these checks and balances going on behind the scenes. But I guess that brings us to, the million-dollar question. Does it work?
Right. That's the question, right? The white paper does make a very compelling argument. All these mathematical proofs, all the safeguards that we've been talking about.
Right.
But I think with anything, especially when you're talking about finance, a little bit of healthy skepticism never hurt anyone.
Right. Never hurts to ask questions. And we have unpacked a lot today. I feel like this deep dive is really just the tip of the iceberg.
Totally. And this white paper, it gives us this really fascinating glimpse into how this whole Ripple consensus algorithm works. But the real exploration, I think, starts when we start asking those bigger questions about, the implications of it all. Remember that question the authors left us with?
Oh, yeah.
About the default UNL?
Yeah.
So if everybody just relied on that default UNL, would that truly represent the idea of a decentralized network? Or would it create a single point of failure? Would it undermine the very foundation that it's all built on?
It's kind of it's a question with no easy answers,
Yeah.
but it's one that's definitely worth thinking about, especially as we, continue to explore this world of finance and technology, which is always changing. So to our listeners, as always, keep asking questions, keep digging deeper. Who knows what other, like, fascinating discoveries are out there? Until next time.